Hi, today we have a little problem to work through with complex numbers. We have this fraction here, which by all accounts looks to be a complex number. It's 1 plus I all to the power of 2019 divided by 1 minus I all to the power of 2017. Well, we want to show that that's actually just an integer. Well, how can we do this? Let's take a look. Let's first let this complex number here that we're given be called W, just for reference. And then to simplify things a little bit, we're going to also let Z be this complex number here, 1 plus I. But if that's the case, that means that its complex conjugate is just 1 minus I. So now, our number W can be written as Z to the power of 2019 divided by Z bar to the power of 2017. But we can break this up. What we have is the following. This Z to the power of 2019 can be written as Z squared times Z to the power 2017. And now because these two quantities are each raised to the same exponent, what we can write now is Z squared times Z divided by Z bar to the power of 2017. Okay, well, Z divided by Z bar, what is that? Well, that's nothing more than 1 plus I divided by 1 minus I. And let's see if we can simplify this a little bit so that we don't have a fraction. We can multiply top and bottom by the complex conjugate of what we see down here. And so what do we end up getting here if we multiply across? We get 1 plus I is 2I. And then plus I squared, well, that's just minus 1. And downstairs we have 1 times 1. We're multiplying conjugates here. And then negative I times negative I is negative I squared, so that's plus 1. So what we end up with here is these 1's cancel, leaving us with 2I in the top. And the bottom we have 2. So in fact, we're left with just I. So Z divided by its conjugate here is just I. Okay, great. So, what can we say? This number W over here, we can now write it as Z squared times, well, we just discovered that this ratio is I. Okay, good. Well, now we're at this stage. Our fractions have cleared. So I to the power of 2017, that's really what's getting us hung up here. But powers of I follow a nice cycle. So let's take a look. If we take the first power of I, we get just I. If we take I squared, that's just I times I, or negative 1. If we take I cubed, that's well, what we just obtained times another I, so that's negative I. And if we take I to the power of 4, well, that's essentially I squared squared, so negative 1 times negative 1, or just 1. Now, if we continue, the next 4 powers of I will follow this pattern, and the next 4 powers of I will follow this pattern. And so these powers of I cycle through these 4 values here. So it just remains for us to determine, what is this power of I equivalent to? Is it equivalent to I to the power 1, I squared, I cubed, or I to the power 4? Well, if we take 2017, that's just equivalent to 1 mod 4. So dividing 2017 by 4 gives us a remainder of 1. Well, what does that tell us? It tells us that this power of I is essentially the same as I to the power of 1, or just I. So now our number w can be written as I z squared. Well, we know what z is. Z is just what we called 1 plus I. So we have I times 1 plus I squared, z squared, and we can expand this out. So 1 plus I squared is just 1 plus 2I plus I squared, which is minus 1. These ones cancel, leaving us with 2I in the brackets. And then if we multiply that by I, well, that means W is I times I, which is negative 1, times 2. And so we get negative 2. And so we see that this answer is indeed an integer. And so we've shown that this seemingly complex number really is just an integer. Thanks for watching.